All right, this tutorial is to do the worksheet that is labeled Net Force Particle Model Worksheet 1, Force Diagrams in Net Force. Question number 1 says, an elevator is moving up at a constant velocity of 2.5 meters per second, as illustrated in the diagram below. The passenger has a mass of 85 kilograms. Construct a force diagram for the passenger. The most important statement out of this is this one right here, where it says constant velocity. Constant velocity. What that means is that all the forces are balanced out. So when we make our free body diagram, we want to make sure that all the forces are balanced by all the forces going up, and all the forces going to the right are balanced by all the forces going to the left. So we're going to first off draw out our gravitational force, because all forces have gravity, and we're going to call that F sub g. And then we are balancing that out by the normal force, because it's standing on the elevator floor, and that's providing a normal force. And that's going to be, the arrows should be fairly close to the same size. So there's our free body diagram. Now, before we continue, because here's the next thing that we're going to have to do, it says to calculate the force the floor exerts on the passenger. So before we can do that, though, we're going to have to get some basics out of the way first. Let's write some formulas so that way we kind of have a basis to make that calculation and make everything work. First off, we're going to start with the net force, because the net force is what's going to cause the acceleration. Net force is what it puts it all together. So I'm going to start out by saying that our net force is equal to the gravitation, or the smaller force, bigger force. So this is the F big minus the smaller force, which is, but we'll get to that later. Right now, both of them are the same size, so it doesn't matter. The other formula that we need to use is saying that F net is equal to mass times acceleration. So net force is equal to mass times acceleration. Some other important things that you need to know. The gravitational force is equal to mass times gravity. And the last thing that you really need to know is that gravity is equal to 10 meters per second squared. Okay, so let's get back to the problem at hand. So what we want to do is we want to calculate the force exerted on the passenger. So what we're going to have to do is, that happens to be our normal force. So we're going to say normal force is equal to the gravitational force, and we see that right here, okay? And we already knew that because what we said up here at the top, that it's moving at a constant velocity. So it all ties in together. All these little clues tie in together to help you solve the problem. So F normal, the normal force, is equal to the gravitational force. Gravitational force, as we wrote down over here, is equal to mass times gravity. So we're going to put that down as mg, as F sub g, and so that's mass times gravity. And then we're going to just plug in our values. So our value for the mass, if we look back up here, we can see that our mass is 85 kilograms. And so we plug into our equation 85 kilograms. And then our gravity which is over here, is 10 meters per second squared. So we're going to put on here times 10 meters per second squared. And that equals 85 times 10, which is 850 newtons. And that's our final answer for part B. Moving on to number 2. Moving on to number 2. Now the elevator now accelerates upward at 2 meters per second squared. So here's the key thing right here, upwards at 2 meters per second squared. So what does that mean? That means that one of our forces is bigger than the other now. And since we're going upward, so it's the upward force is bigger than the downward force. And the upward force in our problem is created by the normal force. So we want to make sure we draw our normal force going up, and that's going to be bigger than our gravitational force going down, okay? And it's just a little bit bigger, but it's still bigger. The next thing we got to make sure we do is we're going to write down our equation for our net force, okay? Because we're kind of looking ahead. We want to make sure that we get the big picture here. And we want to write an equation for the vertical forces on the passenger. So our net force, remember, is our bigger force minus our smaller force. So net force is equal to the bigger force minus the smaller force. Okay, so the bigger force is our normal force, so that gets written down first. And we subtract from there our smaller force, which in this case is our gravitational force. And we can rearrange this because ultimately we're trying to find the force the floor exerts. The force the floor exerts is going to be this right here is talking about the normal force. So that's what we really want to find out. So this value right here is what we want to find out. We need to take this equation, rearrange it for part B. So to do that, we're going to start out with, we're going to add both sides, FG. So we add FG on that side, add FG on this side. FG's cancel out, okay? And we're left with Fn is equal to Fg. So let's write that down. So we're going to say Fn is equal to Fnet plus Fnet plus Fg. We move on. Now we're going to plug in what Fnet is and what Fg is. So if you remember correctly, we wrote that out up here, and you can see that Fnet is MA and Fg is Mg. So we're going to put that down on here and plug that into our equation. So we got M times A plus M times G. Then we plug in the numbers for the equation. So for MA, M is 85 kilograms. A was 2 meters per second squared. And then we're going to add that to our mass, or add that to the gravitational force. And the gravitational force is mass, which is, again, 85 kilograms, times gravity, which is 10 meters per second squared. Okay, and then putting it all together, So we have 85 times 2 is going to be 170 newtons. And we're going to add that to 85 times 10, which happens to be 850 newtons. And that's going to give us our final answer of 1,020 newtons. And that takes care of the first page.